Okay, very good morning to all. So let us talk about the last three questions of your exercise 9.1. So here is your question number 14. Question number 14 is a 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girls at any instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. Figure is given, and then you need to find the distance traveled by the balloon during the interval. So we did one question, that was your question number 6, in which a 1.5 meter tall boy was standing at some distance from the building, and then the angle of elevation we have discussed, and in that case I have drawn the two diagrams and I told you can ignore the height of the boy. So same thing you can do here. If you want to ignore the height of the girl, that is 1.2 meter, then you can take this figure only, that is at the ground level, and what you need to do there, I told you just minus the height of the boy. The same thing you have to do here, you need to minus the height of the girl, which is 1.2 meter given. So I have written the information here. It is CD is the girl and standing with respect to the ground, height is 1.2. So then A and B are the initial and final positions of the balloon. So first position is this, when the angle of elevation in the eye of girl is there, and then second is this, final position B is there, then the angle of elevation reduces to 30 degrees. So at A it is 60 degree and at B it is 30 degree with respect to that. So if you want to neglect the height, then take the eye position here and show this much part only, and the height BH will remain 87 meter at all. So we need to calculate the distance moved by the balloon from the initial position to final position, that is AB. So if you are taking this figure, so AB will be equal to GH and that is equal to EF. Then I did here draw the perpendicular just to take the base if I position is here, and so that CHFD either is a rectangle or a parallelogram. Then at the second position, this is the first position and this is the final position, height will remain same, and accordingly we will be getting the two angles ACG, that is 60 degree, and BCH is equal to 30 degree. So height of the balloon, that is AE with respect to the ground. Now I am taking total, that is 88.2. Similarly the height of this will remain same here, that is again 88.2 BF. So if you want to neglect, that is BH, so then it becomes 88.2 minus height of the girl, that is equal to 87 meter. And now you can study the triangles with respect to this right angle AGC as well as your BHC. So in triangle AGC, you will be getting tangent 60 degree here, and that is equal to perpendicular upon base, that is CG. So this is root 3, 87 upon CG. So CG is equal to 87 upon root 3. Rationalize. So CG length you will be getting is equal to 29 root 3. Similarly in BHC, where you will be doing that, so BH perpendicular upon base, CH is equal to tangent 30, and is 87 upon CH will be equal to 1 upon root 3. In that way you will be getting CH is equal to 87 root 3. So now GH is the distance, which is equal to AB again, because all these A, G, H, B or G, E, F, H are the parallelograms. By construction you can see that. So GH, if you are calculating, that you can take is equal to AB. The difference between CH, from CH, if I will subtract this GH, so sorry, CG, from CH, if I will be subtracting CG, I will be getting GH. So CH and CG, I have written here the values, 87 root 3 minus 29 root 3, and the answer will be equal to 58 root 3. As I have already marked here, AB is equal to GH, and then AB will be equal to, that is the distance moved by the balloon from the initial position to the final position will be 58 and root 3, that is in meters. So answer is this. Then question number 15 now. In question number 15, a straight highway leads to the foot of a tower. So this is the straight highway and this is AB is the tower I mentioned here. Man stands at the top of the tower. So eye position is now at A, and then the angle of liberations we are getting around 60 degrees first. So with respect to this, you have to draw the line of sight. Then if this is 60 degrees, so inside the triangle ADB, this is equal to 60 degree, interior alternate angles, and this outer one is 30 degrees, so this angle will come is equal to 30 degree. And then these are the angles of liberation mentioned in your question, which is approaching the foot of the tower. So car is at C. So I have written here man standing at the top of the tower, spotted the car at C, and after 6 seconds the position of the car will be at D. So I have to find the time taken of the car taken by from D to B. That is BD I have to count the time taken. So I said let U be the uniform speed of the car, that remains same throughout, and T be the time taken by the car in moving from this D to B. So then this distance CD will be equal to what? Distance I know is equal to speed into time. So if the time is time is 6 seconds given from C to D, it is mentioned in the question 6 seconds here. And speed I said is U because that will remain throughout same. So distance CD is equal to speed into time. So here time is given, U into 6 will make it 6U. If it is in seconds, so 6U seconds. And similarly BD from B to D, time taken is T and speed is again U. So U into T it will be equal to UT. So the total distance, then I will study this triangle BC. This will be equal to BD plus CD. So UT plus 6U. U can take common and it inside the bracket it will be T plus 6. Now you study the triangle turn-wise, first ABD and then ABC. So in triangle ABD we are getting perpendicular upon base is tangent 60. AB upon UT is equal to root 3. So AB will be equal to root 3 into UT. Give it number 1. And in whole triangle ABC when you will take perpendicular upon base, this will be equal to tangent 30 degree. And AB you have calculated is under root 3 UT. And BC already I have written there. BC, this is CD is equal to BC. This is BC here. So you can highlight this somewhere BC. BC you can put from this point. This is BC here. And you give it number 1 or you give it number 2. That is from your convenience point of view. You can do that. And put the value here directly. BC is equal to U into T plus 6. Now U and you can cancel. You do the cross multiplication. Root 3 into root 3. Here it is T also. So this will be 3T. Is equal to T plus 6 into 1 will make it T plus 6. So 3T minus T 2T is equal to 6. In that way you will be able to calculate the time, and that is coming equal to 3 seconds that I mentioned here. Let T be the time taken by it to travel from D to B, which was required. So time taken by the car to move from D to B will be equal to 3 seconds. So that is the answer for this question. Then your last question number 16 is the angle of elevation of the top of a tower from the 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. You need to prove that the height of the tower is 6 meter. So here I mentioned that AB is the tower and from B the first point at distance of 4 meter I have taken is C and angle I have assumed is theta. And at the distance of 9 meter point I have taken is D with respect to the A, then the angle here if it is theta it will be 90 minus theta. Why? Because it is given in the question the angles are complementary. So if you have assumed this is equal to theta, so complementary of theta you know is equal to 90 minus theta. Why? Because sum of complementary angles is always equal to 90 degree, and you need to prove here that height of this tower, that is H, is equal to 6 meters. That is required. So now once the figure is complete, you start with studying the triangle. One is your ABC and then another whole triangle ADB. So in ABC I am getting perpendicular upon base, h upon 4 is AB upon BC, that is tangent theta. So tangent theta is equal to h upon 4. This is 4. H upon 4. Number 1. And in whole triangle ABD, you can see that complementary angle will be again perpendicular upon base. Now perpendicular is AB, base is BD, and AB again is h. BD total distance is 9, and tangent 90 minus theta will be cot theta. You know what we did in complementary angles. I asked you to write these in terms of 90 minus theta. There I introduced that, though that was not a part of your syllabus, but from the application point of view you can make a note of all these things. Then from 1 and 2, now you know the tangent is a reciprocal of cot and vice versa. That's why we need to multiply this, and moreover I need to prove h, so my equation automatically will be converted in terms of h. So multiply tangent into cotangent, we will make it 1, and here it is h into h. We will make it x square upon 36, do the cross multiplications. X square will be equal to 36, and if you will be taking the square root of both the sides, you will be getting the height is equal to 6 meter, which you need to prove, and hence proved. So that's all about your this exercise 9.1, which was the part of your application of trigonometry. Now in coming class, I will be adding the assignments to your knowledge based upon the same. That is the end of your trigonometry, which was a part of your syllabus. Moreover, one activity, that is trigonometer, and how to make the trigonometer lively. I will explain that through video lecture only to you, how you can prepare a trigonometer and then how you can use that to measure the height of the objects. Till then, thank you. Bye bye. Have a nice time.